All right, so this is a really exciting video today because the chassis is done on the trophy truck. So this part of the design series, we're going to be going over the exhaust build, the rear axle configuration, and the chassis design. So one of the big packaging constraints that I ran into on this thing was that these drive shafts were interfering with the engine in a really significant way. I had originally had a standard Atlas transfer case in here with about 9 inches of offset, and that just put the drive shaft right smack in the middle of the engine head at full compression. So what I needed to do was offset this drive shaft by about 18 inches from the center line, which is pretty big. There's nothing commercially available that will do that besides like a monster truck drop case, but those have the outputs going the wrong direction. And so I needed to build something custom. And so I ended up making a custom transfer case and going with a dual drive shaft configuration, which I'll get into in more detail in the time-lapse part of the video. But yeah, twin drive shaft is not a common configuration. It is something that has been thought about for a long time by a bunch of different designers, and it's recently been implemented from some pretty serious builders. And I think it's a really good idea because it takes the load off of the part that fails the most often in these vehicles. And since the suspension is done, probably won't talk about that in too much detail in this video, but ended up with 30 inches of front wheel travel, which I'm really pumped about, and 50 inches of rear wheel travel, which is just insane. You know, most trophy trucks have about 3 feet of travel in the rear, which is super nuts. But to go from 30 to 50 on this design, it sounds crazy, but it makes sense in terms of the proportion of the wheel in relation to everything else. Because again, we're running 58-inch Mickey Thompson tires on this. So the purpose of this design study was to see what would happen if you took a trophy truck and scaled everything up by 50% to fit these gigantic tires. It's the same idea that I had for the Ultra 4 in the previous design series, and it allowed me to do some really cool things like have a 4-seat configuration, do a mid-engine drivetrain, and have this really wicked looking cage. My favorite part of the cage is back here because this is the most challenging part of any trophy truck design, which is that you have to tie the back half of the vehicle that supports the spare tires and the fuel tank to the center part of the vehicle that houses the engine and the shocks. And you basically have to build a bridge in between those two sets of tube work. And so we'll get into it in more detail in the time lapse, but the way that I did that was by adding all these curved tubes back here, and it looks really strong. I'm really happy with the way that it turned out. I think the only modification I would make to this, taking a second look at it, would be maybe to add some tie-in points up here at the top. But yeah, it's looking really nice. I have a traditional cage with the X style roll cage on the top of the roof, flying W on the B-pillar, and some really fun looking sheet metal work for the shock mounts and the 4-link mounts. So with all that, let's get into the time lapse. We're going to be talking about the exhaust and then the shock mounts and then the cage. So the first thing I need to try to figure out is how to route the exhaust around the 4-link suspension components. And I'm doing a similar 8-into-1 exhaust configuration like the last Ultra 4 design. I think having the 8-into-1 collector pointed up is a really nice design motif that I want to carry forward into future designs. It looks super crazy, and it's kind of a design challenge to get it to all work out. And it also is a very convenient way to package the exhaust in the system. So what I'm doing is referencing the previous 8-into-1 exhaust design and just grabbing some planes from the engine block that are going to be my output ports on the header primaries, and then just sort of connecting the dots and iterating between the exhaust ports and the collector to see where stuff can live. And this is an instance where I use 3D sketches and then a weldment feature to route those pipes. It's a really quick way to make a sort of complex shape, and it ends up looking really cool in the final design. So I just need to adjust all my dimensions to make sure that none of the exhaust pipes are going to be crashing into each other, and figure out the best place to do routing. So now I've got all 4 pipes in there and it looks like everything's going to clear. So I can just mirror that exhaust over to the other side and check out how it looks. Then now I realize I have a really big problem, which is that offset differential on the drive shaft is going to crash into the entire engine. And that's by virtue of the fact that I was using an off-the-shelf Atlas transfer case, and it has a standard spacing of about 9 inches, but I needed a drop case of about 18 inches, and nobody makes those. SCS makes a drop case that does have that dimension, but the output shafts are both on the same side on the bottom. So that wasn't going to work. I needed one drive shaft going through and then another drive shaft going out the back. So I decided I needed to make a custom transfer case and do a twin drive shaft configuration. So let's talk about twin drive shaft configurations. These are a super hot topic right now in the off-road community. I think it's a really cool idea, and a bunch of people have thought of it and a bunch of people have designed it, but there's only a few people who have actually tried it. And that to me seems like it's a viable solution. So that's what I'm going to go for here. So all I need to do is make some custom gears for the gear set. So I'm just copying over the gears from the portal hub and increasing the diameter. And then this is going to be a really wide transfer case. I need 18 inches on either side. So the whole thing's going to be 3 feet wide, axis to axis, which sounds crazy saying it out loud, but that's the only way I was going to be able to clear the big block that I have in this assembly. The other advantage to a twin drive shaft configuration is it reduces the load on the pinion gears, which is a common failure point in the diff. So now your rear axle is going to have 2 diffs, and each diff is driving one wheel, but diff is actually a misnomer. It's not actually a differential anymore. It's a spool gear that's fixed drive shaft output to the wheel, which is kind of interesting. So I just need to make a really simple slot shaped housing for this and make sure I have enough room for an O-ring groove and some bolts to clamp it, and then some bearing journals to capture the gear set. And it's pretty straightforward. So I have 5 gears in this configuration. There's 1 center input gear, 2 output gears, and then 2 idler gears. And the reason for that is that it keeps everything rotating in the correct direction so that I don't have to have any reverser gears between the engine and the wheels. And the great thing about diffs and pinion gears is if something's rotating the wrong direction, like in a mid-engine configuration, you just flip the diff upside down or mount the ring gear on the opposite side, and it gets your rotation going the right way. So these are just some little bosses to capture the bearings, and I can start packaging everything in. And so I'm using the same tapered roller bearings that I did on the portal hub. I found out recently that it's not the best bearing to use. I should probably be using a needle roller bearing because tapered roller bearings require shim spacing for preload, and it makes assembly a little bit more complicated. I found that out from a really great video that 74 Weld just put out, which was a deep dive of how their portal hubs work and everything from material selection to their manufacturing process to exactly which type of bearings they use and why. And that's a big consideration for them. They don't like bearings that you have to preload. They just like bearings that you can drop in, which are needle roller bearings. So I'm probably gonna have to go back and modify this design if I can find the right bearings on McMaster to suit this application, or just reach out to the guys at 74 Weld to see who they use and what their supplier is for bearings. So now I can drop this into the assembly and see how everything looks. So now I have sort of the daunting task of redesigning the entire rear axle. And this ended up being kind of tricky because all the mates were in weird places and the center plane was in a strange place. And luckily the parts in here were simple enough where I didn't have to rebuild it from scratch. I was able to adjust the existing components in there because they're really simple shapes. It's just tubes and flanges basically. And then I needed to increase the distance between the diffs and therefore the mounting points for the 4-link, which simplified the 4-link mounts, but made the gusseting a little bit more complex. And so this probably looks weird to everyone. It looks weird to me too, but there's 2 differential housings in here because it's a twin drive shaft configuration, which, like I said previously, a lot of people have been thinking about this for a long time, but recently there's certain prominent race car manufacturers who are trying it, and this is a little bit of monkey see, monkey do operation here. And it just so happened to fit the assembly. And if it wasn't for this type of design entering the off-road zeitgeist, I would have been completely stuck on this design. I had a different idea for a twin drive shaft configuration, which was sort of like, I would describe it as more of like a motorcycle style swing arm where the drive shaft is embedded in the swing arm. And then if you were to apply that to a trophy truck, the drive shaft would be embedded in the trailing arm. But the gear pivots would be super complex and a completely novel design, whereas something like this, you're taking existing hardware like drive shafts and differential housings and just doubling them. This makes a lot more sense. The reason to do a motorcycle style swing arm is that you could have really long articulating independent rear suspension. I might try a design like that someday. I think that would be really cool. But there's a certain advantage to having more unsprung mass on trophy trucks. The rear solid axle is sort of your anchor, and all that weight back there sucks the wheels back down to the earth for traction rather than just relying on the springs. So I think that's why independent rear suspension has not taken over in the trophy truck world. It certainly is winning in the rock crawling aspect of Ultra 4, but rock bouncing and trophy trucks still use solid axles. And I didn't want to get too radical on this design. I was just trying to make a traditional style trophy truck with 58-inch tires. So I guess that part is kind of radical, but didn't want to go too crazy. But a twin drive shaft configuration makes perfect sense for this application because there's just so much load on those ring and pinions driving those tires, even with the portal reduction. And it also happened to be the only solution that would work for clearing the giant big block that I have in the mid-engine configuration. So on this top gusset, I decided to do away with the sheet metal because it was going to be a big wind trap. And in place of that, I put a trellis frame, which is that tube work that you see. The reason for that is it adds a ton of rigidity and it allows air to pass through more easily. And it's hard to get a sense of scale in this model, but the distance from the center of the axle to those pivot points is 15 inches. And so it's just a really big space to fill, and especially a really big space to make it strong and rigid. So trellis frame was a perfect application for this. So that's what I did. So the next thing that I'm going to start on for the chassis, this is the first component in the chassis, is the 4-link mounts. So that bottom pivot point is for the trailing arm, and then the top pivot point is for the 4-link linkage. And I'm taking inspiration from a fabricator called Ocho Fab. He has a really great set of 4-link mounts, and I think they're really designed really well stylistically, and they look strong to me. I mean, it's basically boxed sheet metal, which is hard to pull off, but the goal for this is to have one plate holding one side of a bolt and that same plate holding another side of the bolt, because the trailing arm and the 4-link are offset. And so I set that offset spacing so that I could use one plate in between the two bolts, and it ended up working out really nicely in terms of packaging. And it also made the sheet metal modeling fairly straightforward because I can just box one side and then box the other side, and then the whole thing is tied together. The other advantage to this is that long triangle shape that you see allows a really big tie-in point to the rest of the frame, which this component is going to see the most load out of anything because it has all of the shock load from the rear suspension and all of the driving force from the rear wheels. So you should be able to hang the whole car upside down by these points because there's so much G-force on them as the car bounces through the whoops. And so for the sheet metal modeling, I'm just trying to select planes where I can make a bunch of triangles that tie to each other. That way it'll be easy to model, easy to cut, and really easy to fab as well. And triangles are a really strong shape. And as long as I have all my load paths tying into each other, it should be able to take whatever force I throw at it. But something like this, you really couldn't run this through finite element analysis. At least I don't know how to run sheet metal through finite element analysis. It's just one of those parts that I'm sort of eyeballing and trusting my inherent tendency to overbuild things and hoping it's really strong. This is also 1/4-inch plate, which is definitely overkill. I mean, just hold up a ruler and look at how big 1/4 of an inch is and imagine that's steel. It's really, really thick. But everything on this vehicle is oversized by about a factor of 1.5. So I'm not super worried about weight either. I'm just worried about strength. So one other small issue that I had to fix was that the new custom twin output transfer case was interfering with the rear seats. It was going to crash into the passenger's legs. So I had to move this entire engine and drivetrain assembly back a foot, which I had plenty of clearance in the rear, and more rear weight bias is fine by me, but I had to adjust some drive shaft lengths to get everything in the right place. And now the passenger's legs can clear that transfer case, and they'll be nice and comfortable back there as they're flying through the desert. It also leaves a little bit more room for the fuel tank and the radiator. So now we're actually working on the chassis. And whenever I'm designing a chassis, the things that I think about first are the profiles. So what I mean by that is, what does the bottom profile look like and what does the side profile look like? And then you can sort of project everything out into 3D space around the components and the suspension and the cabin. And that bottom profile is going to be the base of the frame, which I decided to make out of square tube. It's just going to make everything a lot easier whenever I need to land a roll cage piece. And I'm making these bottom frame rails 3-inch square tube, 1/4-inch wall thickness. So the fact that they're oversized is going to make the roll cage tie-ins a lot easier because you can weld all the way around a 2-inch tube onto a 3-inch square tube. And so that's what we're doing right now with this weldment feature. So I just have a regular sketch on that bottom plane, and then I'm just tying in these weldment structural members one by one. And the tricky thing about this in SolidWorks is that you have to get the sequences of your tubes correct. Otherwise, the coping won't match up correctly. And so it's basically just trial and error because you never really know what SolidWorks is going to do in terms of coping. Sometimes it's perfect. Sometimes it's a completely ridiculous shape that you can't even understand why it chose it. So I have a base frame under the cabin, and then I have a long extension out to capture the engine on the bottom side. And the goal for this design is to be able to pull the engine out from the top, just like a regular car. And the whole bottom of the vehicle will be plated in and completely smooth, one flat plane of that square tube. And there were some times on this design where I was checking the clearance on the rear suspension components, and I thought I had done something wrong. Like I got a mate wrong but it turned out to be right. There's just so much droop on this car, so much travel, plus or minus 15 degrees, I think, which is it with that long, giant trailing arm, it yielded 50 inches of rear wheel travel. So it's just kind of crazy to look at full droop. And yeah, there was a lot of times where it just didn't look right until I remembered that everything is set up correctly and it's just an insane amount of travel. So the next most important part of the design is the side profile of the vehicle. So what is the windshield angle? Where's the A pillar, B pillar, and the back of the cab going to be? And does it look right? Does it look like a truck? And so I actually imported in an image into the sketch of a modern crew cab truck just to make sure I had all the proportions correct. Because the last thing I want to do is get to the end of this design and all the suspension is exactly how I want it and the cage is really strong, but it looks, if it looked goofy or if I didn't like the way it looked, that'd be a gigantic waste of time. But the side profile of the truck ended up looking somewhat reasonable compared to modern vehicles. I know trophy trucks are a totally different shape and scale than normal trucks, but especially something like this, everything's bigger than it needs to be to accommodate those tires, but I still wanted it to look right. And the tricky thing about a trophy truck chassis is that you have all this tube work in the center of the vehicle around the cabin, and you have all this wheel travel in the rear in the solid axle. And then way behind at the end of the vehicle, behind the solid axle, are the spare tires in the fuel tank. And so you have to figure out a way to build a bridge between the cabin and those spare tires in a way that's going to allow clearance for that solid axle. And what ends up happening is you have this box hanging off of the back of the vehicle that needs to be tied up and over to the center of the vehicle. And it can be sort of tricky to get those dimensions right and make sure everything's going to be strong enough. But I think I ended up coming up with a decent solution for this. So the other super challenging part of this chassis design was the front bulkhead, because I have to figure out a way to tie in a center tube at the bottom front of the vehicle to all of the front suspension components. So the lower control arm is easy because it's just a tie plate between that center spine rail and the lower control arm pivot points, and they're right there. But there's a bunch of tube work and plate work that needs to attach to the upper control arms, the sway bars, and all the steering components, and be rigid in all three directions. So there's a lot of builders that will select a pre-designed or pre-built front bulkhead. The one that I'm thinking of is from Triton Engineering. He has a really great off-the-shelf front bulkhead that ties in the diff and all the pivot points and even all the arms if you want them, because it's just such a packaging challenge to get everything in there, tied in, strong, and in the right place. So the first thing that I'm doing is just putting the plate work in for the pivot points, and then I'll build a skeleton of tubes around that. So these plates on top are for the upper control arms, and same thing for the shocks. So the other interesting thing about this design process that is counterintuitive is that I'm designing it backwards compared to how I would build it. So these chassis suspension tie-in plates would be the last thing that you do after you build the cage. But since they're already fixed in space for the suspension geometry, I'm designing them first, and then I'm going to build the tube chassis around them. Whereas in the fabrication process, you would build the tube chassis first and then add those plates in last. But this is the most efficient way on a time scale to do this design, because the tube work is really complex. These plates are really simple, and they are your primary constraints. So getting them in first and then designing the complex tube work around them after the fact is the right move, in my opinion. So now I just need to integrate the front differential into that front bulkhead, and I want it to be tied in by plate work so that rather than bolting the diff to the chassis, the diff housing itself is welded to the chassis, because this part is going to be seeing a lot of load. It needs to be fixed in place, and the housing is already made out of chromoly, so I can just weld it in with plate work to the chassis as it exists without having to modify too much. So now on the rear part of the chassis, I need to build a bridge between the main cabin, the engine mount, and the rear spare tires. And that bridge is going to allow for clearance for up travel in the rear solid axle. So I'm just using a set of arcs here to keep sort of a truck looking profile, where the bed of the truck is where the engine lives. And there's plenty of tube work to tie the spare tire carriers to the rest of the chassis. And this is really the only part of the chassis that I used crazy bent tubes. The rest of it is sort of just boxed in a traditional sense, because if you remember on the Ultra 4 design, that tube work was stylized because there's no body work. So the tube is the most prominent aspect of the vehicle. And I wanted the chassis to be sort of a piece of art. Whereas on this one, I want the structure to be there, as simple to fabricate as possible. And then the body work will take care of the stylistic element of the design. So the next most important thing is the rear shock mounts. And these are tying into the top back corner of the cabin. And these are also super critical because they see a ton of shock load, and they're an incredibly prominent piece of fabrication work. So you want these to be cool looking. It just can't be a big goofy plate. It's got to have some sort of stylistic element, and it has to point the loads towards the correct node in the chassis. So those two circles where the shocks mount are going to transfer their loads up into that top corner along these arcs. And then I'll have cutouts on the plate work and then box everything in so it's really, really rigid. And so that's what those sort of shark fin looking shapes are used for. Just something that looks fast and also directs the shock loads in the right direction so that it's as strong as it can possibly be while still looking cool. And then I can just take those existing profile sketches and make some box features to tie everything together. And that looks plenty strong to me. And it looks great in the upper assembly. Same thing for the rear bump stop mounts. I'm using that same shark fin motif on this design. And this is a lot simpler piece because it's only one tie-in, and the node that it's connecting to is right above it. So I don't really need to direct it too far, but I'm still arcing it and stylizing it so that it will match the upper shock mount. And then I'll be building the chassis around those anchor points. So since these pieces were in, and these are the most important, that's what I decided to start with first. Rather than building the chassis from front to back, I started with the most important structural members and then worked my way out from there. So I sort of started with the center of the chassis at those shock mounts and then worked my way backwards to the spare tire mounts. So this was honestly the easiest part of the design because everything that it ties into is right there. Like those spare tire carrier cage points are a really simple shape, and I'm able to tie everything into that bottom square tube frame rail with straight tubes in a lot of places. And then I'm just adding curvature shapes where it makes sense on that bridge portion between the center of the chassis and the rear of the chassis to leave room for clearance for the solid axle in full compression. And I'm just building a cage around the engine in a way where it ties in the rear shock mounts, but still allows for you to remove the engine from the top using a regular hoist. Because that was a big issue on the Ultra 4 design, was that the engine was completely caged in from the top and the bottom and the sides. So I was going to have to do some sort of tube coupling on that to be able to remove the engine. But on this one, the portion of the cage above the engine is open. So now on the front part of the chassis, there's a lot more design constraints on this because you have a center spine and then everything else has to tie in around it. So there's not really a great box to attach everything to. I just need to sort of work my way out with the center spine and then some ribs that will tie in those existing plates. And I decided to use that front winch as a constraint for the front of the cage. But I think I'm going to end up modifying this design when we get to the bodywork phase because I want to have a traditional trophy truck style front bumper. And I'm not really worried about ground clearance in the same way that I was for the Ultra 4 design. So I'll probably move that winch out and have a bumper that's going to wrap around the front of the wheels. But just some simple plate work here. And then I can make some tubes that pop out and around that winch to tie the upper control arm plate mounts to the lower control arm plate mounts and the center spine of the chassis. So the front bulkhead tube work is starting to come together. The biggest limiting factor on here was the steering box to make sure that none of the tubes were going to crash into that. But the center tube that you see there is for the sway bar. So that was a really nice anchor point to tie everything to. And the plate work was super simple on the upper control arm mounts and basically just building a load path around those from the top of the bulkhead down to that center spine into the rest of the chassis. And you want this part of the design to be really rigid torsionally because the independent front suspension is going to be imparting a twisting force along the center axis of the vehicle. So it's got to be really strong. So now for the rear part of the chassis, I'm using a lot thinner tube. So I'm using 2-inch chromoly tube everywhere, but the stuff in the back is 0.63 wall thickness because there's not a lot of weight back there. There's only about 600 pounds worth of tires. And although it is sort of flopping out there in the wind at the back of the vehicle, there's no shock loads from suspension. It's just gravitational loads from those tires bouncing up and down. So thinner wall back there, I think it's the right move. I just needed to make some clearances on that sway bar to make sure it was wide enough. And I added a little kick out on there. And then these arcs that you're seeing here are the bridge tying the spare tire carriers to the rear of the chassis. And most of the load is going to be vertical. I don't imagine there's going to be a lot of lateral loads on this unless you crash, in which case it'll break a bunch of stuff. But all the constraints are vertical on this part of the spare tire carrier. And those arcs are a really great way to tie in all the points to the main chassis and leave a ton of clearance for the rear solid axle to cycle at full compression. So I'm really liking the way that looks. So now I'm going to tie this in to the mid-engine / shock load part of the chassis and still using 2-inch chromoly, but this is a 120 wall thickness because I want this to be the strongest part of the vehicle. So I'm basically just adding all the tubes that will capture the shock mounts and take the loads. And then I'm following load paths so that I can see where I need to add gussets and where one tube will do the job, because I don't want this to be overly complicated. It still needs to be stylized and designed, but it doesn't need to be crazy. This is another motif that I liked from the previous design, which is I added a tube around the outside of the shocks so that in the case of a rollover, there's at least some protection around the shocks because they'll just buckle with a side load. And it sort of protects everything in there and still leaves room for the tire. And it looks awesome. So here's another example where I had a weird coping on the SolidWorks weldment feature. you basically just have to chase your own tail until you get the sequence of tubes right. And it still wasn't perfect in SolidWorks. I had to chop off a portion that SolidWorks decided to add in that I didn't want. But I usually separate the portions of the chassis into different features. So the rear section is separate from the front section, is separate from the center section. And the reason for that is every time I add or modify a portion of the 3D sketch, I don't have to rebuild the entire chassis from scratch. I'm just able to modify that one portion of the model without breaking everything else. So the next thing I need to start thinking about is the cabin. And the primary constraint on this part of the cabin is the front, where the wheel is at full lock and full compression and needs to not crash into the cage. So I actually found a little interference on my lower control arm that I needed to take a big bite out of. I'm making sure that there's enough room for the driver's feet at full lock and full compression, and there's enough room for the cage so that it's not going to rub on the tire. It's very seldom that you would have your vehicle at full lock and full compression, but in terms of the design, it still needs to cycle properly. Most of the time, when you're landing and your front wheels are at full compression on a jump, you're not going to have your steering locked. It's just going to snap the wheel off. And most of the time when you're at full lock steering, you're going to be going really slow and your front suspension is not going to be fully compressed. But again, it's just a best practice for this design. So I'm just adding the side rails for the tub for the chassis. And these are really simple. I'm just following the profile of that bottom part of the frame, tying into that front bulkhead, adding an arc to clear the tire, and then some vertical down tubes to land on the base of the chassis. So the next thing I need to make is this subwoofer mount. I love listening to bass music really loud, and I love subwoofers. And since this was a mid-engine trophy truck, there's a big gap right in front of the driver where the engine usually lives. So I decided to put a 15-inch subwoofer there, which I know is silly, but this is not a race car. This is a fun car. And I wanted to bump when we're bouncing through the desert. So it ended up being a nice surrogate for firewall, is this big plate that captures the subwoofer with a little port, and it tied the bottom of the chassis to the top of the bulkhead really nicely as well. And it just so happened that the tubes fit where I could get the biggest commercially available subwoofer in there, because that's what this is about. This design is all about the most ridiculous stuff you can put in a vehicle, like 58-inch tires and a 15-inch subwoofer right by your feet. Same thing for the rear passengers. That's a 12-inch subwoofer back there. So they're not left without any tunage. So now I'm just tying in the chassis sidewall tub to the rear shock mounts, and then I can start thinking about what the top of the cage is going to look like. And I need to be careful here because I don't want any of these tubes to be pointing in a weird direction. I want them to land perfectly flat on that square tube so that they're as strong as they can be. There's not any weird coping, weird angles, and the welds can be perfect. So that little kick out down at there at the bottom to make room for the 4-link mounts ended up being kind of a challenge because I had to have some of the tubes going at strange angles, but it ended up being okay. So then the front windshield, I'm going to have 3 tubes tying the front windshield in. So there's that standard V shape that you see on a lot of cars, on a lot of trophy trucks, I should say. And then I have 2 other ones that tie the top corner of the top of the cage to the side wall tub. So I'm adding a radius here at the top, and then I have 2 additional arcs in 3D space that are going to tie everything in. And there's plenty of visibility, but this just makes that A-pillar 3 times stronger than a typical design, because rather than 1 A-pillar tube, I have 3 of them. And then I can just gusset everything in. And the top of the cage is a standard X shape, and so is the B-pillar. The B-pillar is a traditional flying W configuration, or maybe it's a flying V. And it's just that classic trophy truck cage style that you see where it's that big crazy X on the top of the cage that you look up from the inside of the cabin and it looks like you're just bomb proof. So now it's time to add the tubes for the main cabin part of the chassis, and this chassis design is almost done. I really like the way that this turned out. The traditional styling on the cage, as well as some other design motifs that I wanted to put in, and straight tubes wherever I could get away with it, and curved tubes where I needed them. Made it really strong, and I'm really happy with the way it turned out. And so now this chassis design is done.